Okay, hello everyone. Welcome to today's webinar. My name is Freddie Holmes. I'm part of the editorial team here at Automotive World. I'll be chairing today's session, which will take a look at EB tresos Studio and AUTOSAR Builder. These are two software tools that, when combined, can help to increase productivity. As we'll hear from our experts in a moment, automotive systems have become increasingly complex and rely on more software than ever before. A number of tools exist which can help to integrate the application software layer with basic software, but interoperability between these two tools can prove a challenge. Now, given that both EB tresos Studio and AUTOSAR Builder are based on the AUTOSAR data model, this ensures full AUTOSAR compatibility and makes data exchange between both tools seamless. Giving us more detail on this today will be Elektrobit Drees, as well as Michael Seibt from Dassault Systèmes. We'll close today's session with some audience Q&A, so I'd encourage you to get any questions that come to mind to us during the presentation itself, and you can do that through the Q&A box, which is at the bottom right-hand side of your screen there. And that's all from me for now. I'll hand over to Dennis and Michael for your presentation. Chaps, please take it away.
Again, we already talked about the AUTOSAR development flow. This is what I meant when I mentioned the application layer as well as the AUTOSAR basic software layer. The interoperability between the tools enable you to do both in a productive way. So if we look into why that is much easier than with other tools, is because both tools are based on the same AUTOSAR data model. Both are working with Eclipse, and the AUTOSAR Builder is also currently supporting AutoSAR. On our side, we're working on that as well. I think the rest we've already spoken about.
Right.
To you.
So here again, this overview on AUTOSAR Builder. So I make it brief. We will see more detail in the live demonstration. AUTOSAR Builder is the AUTOSAR authoring tool, which allows you to model everything related to the software component, the template, and the system description template. This is underlined with validation rules, which check your design in terms of consistency and completeness. And once you're finished with your system description, you have different ways of export this information towards the basic software configuration tool, such as an ECU extract or system description or system extract. And then once you have done that, you hand this over to your basic software configuration tools, such as EB tresos Studio.
Yeah, and also keep it brief. We support the AUTOSAR methodology, the AUTOSAR flow. We make it easy to integrate with other modern tool chains, which makes configuration of third-party modules possible as well. The one single environment aspect of it allows you or gives you the flexibility to use the tool in various ways and therefore enhances efficiency.
So now getting back to this overview. So this slide shows the general AUTOSAR tool flow and how an AUTOSAR authoring tool and a basic software configuration tool exchange with each other. So looking into the left block, which represents the AUTOSAR authoring tool, you create your software component description in terms of software components, interface descriptions, the internal behavior. Based on this information, you can generate the so-called RT config phase, which will generate the header files for your application coder. So once you have done that, there are now two ways to proceed. So in terms of the implementation, so either you manually code your application, or you use model-based design tools with code generation, so like MATLAB Simulink with embedded coder, or there's TargetLink, for example. Others like was mentioning like Seibt or AUTOSAR, which provides such kind of capability. So next to the software component description, you also need, due to the AUTOSAR standard, to describe the ECU resource description. So this has become kind of neglected over the last years. So today you don't need to provide much information from there. More important is the system description. So here there are two fundamental parts you need to provide. One is the communication matrix, which you in generally get from your partner or from your customer, which you import, or there are also use cases where you need to create at least part of the communication matrix, and the ECU topology, which describes your bus clusters and the ECUs which are connected to the buses. To complete the system description, you'll need also to provide the mappings, so in terms of the software component to ECU mapping and the data element to system signal mapping. So once you've done that, then the handover towards the basic software configuration tool will be either the ECU extract or the system extract. So this brings us to the next phase, to the basic software configuration. Once you have imported the extract, you need to configure your basic software in terms of configuring the RTE, the operating system, the individual basic software models, and the ECU abstraction components. Once you have done that, you apply the code generators, which will finally generate the RTE, the OS, the basic software, and the microcontroller abstraction layer. So at the end, you get a bunch of C and header files which need to be compiled and linked, and at the end, you get your executable, which you will upload to your target. So how does this look like in more detail when you work with AUTOSAR Builder and EB tresos Studio? There are quite a bunch of scenarios possible. So we have sketched here the two, we would say, most common scenarios. So the first one we see here is you start with EB tresos Studio. And what you're going to do as a first step, you will import the standard and platform types, which are provided by your basic software. Once you have imported them into AUTOSAR Builder, you will first create your software components or compositions. Then you assign your interfaces, application and service interfaces, and then you create your top-level composition, which means you connect your software components. In parallel, you import your communication matrix, which defines all the messages in terms of signals, PDUs, frames, and the triggerings. And then you need to define the mappings, like software component to ECU mapping, which describes which software component will be executed at the end on which ECU, and then the data element to system signal mapping, where you actually map your communication matrix over your software architecture. So before you generate the ECU extract or system extract, you will run the EB tresos validation profile. So this is a dedicated group of rules which check whether everything is there, what is then needed by EB tresos Studio. So when the run was successful, you can generate the ECU and system extract and hand it over to EB tresos Studio for the basic software configuration. So on the next slide, you see another possible use case. Here again, you start at EB tresos Studio, reusing the standard and platform types, importing them into AUTOSAR Builder. What it will do in addition, you will pre-configure your service components in EB tresos Studio, which means you first create or generate your service interfaces, create your service components, and then assign the service interfaces. So once you have done that, you import your service components into AUTOSAR Builder. The next step in AUTOSAR Builder is once you have created your software components on the application layer, you will connect the application software components with your service components. And then the next steps are as the use case before, so you import your communication matrix, create your mappings, run your validation profiles, and at the end, you generate either an ECU extract or system extract and hand it over again to EB Tresos Studio for the basic software configuration. Quite important here is when you do all the individual design steps that you iteratively run the different validation profiles. So here, as you can see on the right side in AUTOSAR Builder, there are quite a number of validation profiles implemented, which need to be executed in different design phases, like after creating the software component or your compositions, or like after importing the communication matrix to get sure that all the data are consistent and complete. So at the end, I want to emphasize this again, before you export your ECU extract or your system description, run the EB Tresos Studio validation profile to get sure that everything is there, what is actually needed done by EB Tresos Studio. So when we talk about the interaction between AUTOSAR Builder and EB Tresos Studio, also an important topic is the AUTOSAR round trip. What this actually means, I try to describe this here. So here you see the typical flow. So normally you start by getting some data from your customer, some AUTOSAR XML files, which you import into AUTOSAR Builder. So depending on the customer, the data have different type of granularity. So what you normally need to do, you need now to integrate into this existing data, which could be, for example, a software architecture with some software components provided by your customer, and you need to develop your own software components and integrate them into your top-level architecture. At the same time, you usually get a communication matrix from the customer, which you need to integrate in terms of the data element to system signal mapping. So, and again, so once you're finished, you generate your extract and hand it over to EB Tresos Studio to configure your basic software. But now there are cases where you might induce some changes, like let's say, for example, on basic software configuration side, you decide that you modify a service interface by adding, for example, an additional service. So at that point, you have to feed this changing back to the AUTOSAR Builder tool to take this change into account. Or what also happens quite often, that you get an updated file or deliveries from your customer, and you need to take those changes into account. So one way to handle that is using this compare and merge tool in AUTOSAR Builder. So this is a utility in AUTOSAR Builder which allows you to compare different AUTOSAR projects on an AUTOSAR level. So it's not just a textual compare, it's really an AUTOSAR level or AUTOSAR aware compare, which shows you the differences of two projects in terms of whether it's just different or whether an object exists which doesn't exist in the other project, and so on. And once you have identified the changes, you can then commit the changes and merge it in your existing design. So now let's turn over from the theory to the practice, and we would like to give you a short live demonstration on how the interaction between AUTOSAR Builder and EB Tresos Studio works. So here you see now the user interface of AUTOSAR Builder, the all-string tool. Here on the left upper side, you see the different views and editors related to the different AUTOSAR templates. Like here we have the software view or editor addressing the software component template. Then we have one editor related to the ECU resource template. And last but not least, we have two editors to address the system description, which is partitioned here into the network, which is addressing the communication matrix, and the system, which is specially addressing the mappings. So looking into the software field, so let's look at this simple example. Here you can create new software components. You can, of course, display them and, of course, change them. So let me open a software component. So what we see here, let's make it a little bit bigger. Here we see a single software component with its ports, and you see each port has a box attached which describes the assigned interfaces, including the data elements, or in terms of our client-server communication, the operation and the operation arguments. If you want to dive into the software component, you see on top here this green box. So if you double click on it, you dive into the internal behavior, which shows the runnable architecture of your software components. So for example, here we have two runnables with related RT events and access points towards your ports. So looking now at the overall architecture, we see this here quite well. So this is the overall architecture of this application. So it's a simple a blinker light application, which shows here that the 5 software components on the application layer are connected with each other. So this will be the software part. Let's have a look at the system part. So if we look at the system description, one representation is also on the graphical level. So let's open the related diagram. So here, what you see on top, this is actually the ECU topology. Let's make it a little bit bigger. So we see here a simple example. So the blue line is actually our CAN cluster. Connected to the CAN clusters, we have now 3 ECUs, and below we see our software architecture, which is mapped to our ECU topology. Yeah? So highlighted by those dotted lines, you see, for example, that the stop lights trailer actuator is running on the my actuator ECU. What you see in addition is the communication matrix. So these are those yellow arrows. This arrow shows actually the signals which goes into the ECU my actuator. In contrast to this arrow here, these are the signals which are sent out from this ECU. So this is a graphical representation of your communication matrix. So how interact we now here with EB Tresos Studio? So we have here now a complete system description. Before you generate your export, get sure that you execute your EB Tresos Studio validation profile, which is selected here. So to execute this, just press this icon here, and everything is fine, which is the case here. You do not get any error or any warning. So we are ready now for creating the ECU extract. To do this, there are different ways. One way is that you select the related submenu ECU extractor. You can validate again if you want. We just did that. Select your system. So in this case, we have just one system description created, and then you need to select the relevant ECU for which you want to create an ECU extract. So I select now my body ECU, and then you click OK, and then you just need to specify your target directory where you want to store the ECU extract. So now we can switch over to EB Tresos Studio. So the first step you need to do, so I start from scratch, you create a new configuration project. So you need to provide a name, of course. So let's call it my ECU extract from AUTOSAR Builder. Then you click next. Then you need to provide an ECU ID, and you need to specify the target. So here it's Windows. Then you just click next, and here you have already a preview of your model configuration. Then you click next, and this important step you have now to define an importer. So click on the plus sign, give the importer a name, and get sure that here in this drop-down menu, select the system description importer. So the system description importer allows you to import the system description, a system extract, but also an ECU extract. Then you can keep the mode import only. Click on next. Then of course you need to select the files to be imported. So in this case we take this ECU extract we have just created in AUTOSAR Builder, and then we are almost there. You can check here, validate against XML schema. You can also select your strict schema. In the meantime, EB Tracer Studio also supports standard schema. Then click on next. You can keep here those settings, and then you finally click on finished. And once you click the final finished, EB Tracer Studio will also apply a validation profile to get sure that the imported ECU extract is valid. And as we can see, this looks pretty good. So we have no errors, just one warning. So in the ECU extract, there was also a timing constraint defined related to the timing model. Of course, this is not needed now for the basic software configuration, so you can ignore this information. So this is how the export-import works. Then I would like to show you another use case. So let me close those windows, which we do not need anymore. So remember in one of the slides, so this was scenario 2, we were also describing on how you could pre-configure a service component, including the service interfaces in EB Tracer Studio, and import this into AUTOSAR Builder and connect this to your application layer. And once you have done that, it's the same procedure again. You create a system description and generate your ECU or system extract. So how do we get now the data from EB Tracer Studio? So in this case, the service components into AUTOSAR Builder. So there's a quite convenient way. So you open your File Explorer, select the file, and just do a drag and drop into the affected project. So I've prepared a project import ECUM. Then this is an Eclipse thing. You can either copy the file, or you can just link or reference to the existing file as you want. So once the file is imported, let me switch to the software view and get to the related sub-project. So what we see here now is a software component which was already part of the project, and now also a service component related to the State Manager, which comes from EB Tracer Studio. So what we do next, we connect our application layer with our service layer. So one way to do that is, so here we see our software components. You see right now it doesn't have any ports. So what we do, we will first create a composition. So you need to give it a name, a short name. And then we have an empty composition. So I will open this also in a graphical editor. And to instantiate now our application software component, we just drag and drop it into this widget here. We do the same for the ECUM service component. And now we need to connect them. So I take this current mode as service port. And when I move over it, so let's make it a little bigger. move it over, you see that the cursor is turning into this plus sign, and then I just drag and drop the port, and now the both software components are connected. Let's make it a little bit nicer. Here we go. So now we have connected our application layer with our service layer. And then it's the same procedure like before. You complete your software architecture, including the service components. You map your application software to your ECU instances, and then again you generate your extract. So then I have one more example prepared. This is related to the round trip. So remember, there are always cases where you get updated files and you need to take the changes into account. And as mentioned before, in AUTOSAR Builder, there is a compare and merge tool which allows you in a convenient way to identify the changes and merge the needed changes. To use the compare merge tool, I've prepared here two example projects. So this is my original project and a Blinker system, and this is my updated project, Blinker system update. So to compare now the content of both projects, you select those projects, do a right mouse click, and then you select the submenu AB tools, compare with each other. Then you need to specify what is the project you do not want to change, and this automatically defines the other project you merge into. So the project I do not want to change is my Blinker system update project, which contains the changes. Then I click on OK, and then you can just define whether the system to be merged to will be represented in the next window on the left side or on the right side. So for me, it's more intuitive when I merge from left to right. That's why I select here Blinker system, and then it will launch the compare and merge tool. And what you see here on top, these are the differences between both tools. Not between both tools, between both projects. And on the bottom side, you see two columns. One is the Blinker system update project, which contains the changes. On the right side, we see our original AUTOSAR Builder project. So, and by, for example, diving into the tree, we can then identify the change. So, for example, here is you see on the left side there is an ECU instance in the change which doesn't actually exist on the other side. Or let's take another example. For example, here we have a change in the interface, which is quite a common use case. So let's look into this, what has actually been changed. So there's an interface which is called brake sensor IF. So this is the short name of the interface. And we see here there is a data element, brake status new, so which shows that this has actually been added. So in the new file, our partner or customer has added a new data element, which we can now then merge into our original design. To do the merge, you select the affected element, and then you see on the right upper side those different arrows. And here you can decide what you want to merge, whether you want to merge all changes, or in this case, I just want to merge this selected element. So you just click on this arrow here, and once you click on commit, the change will be taken over. And by this, so you can really control, or first of all, identify what is actually being changed, and can really control what changes you are actually taking over. So let me cancel it. So this is it from my side on the demonstration. And now we will be ready to get your questions.
Let me quickly summarize what we have seen. We are looking at what we have looked at both tools. We've looked at the AUTOSAR tooling methodology, once in theory, once in practice. We have gone through 3 scenarios, common scenarios, again, once in theory, once in practice. And we've seen that there is a seamless data exchange flow between both tools following this particular workflow. Yeah, and if you have any questions to that, please let us know.
Perfect. Thank you, Michael. Thank you, Dennis. As you've mentioned, we do have some time for audience questions. So if you'd like to pose a question to our panelists, please use the Q&A box at the bottom right of your screen. I think we can kick off with a few points to clarify with. The first one here, will both EB and Dassault support adaptive AUTOSAR? Another couple of technical questions have come through. Is it possible for operating system scheduling simulation for a specific target in AUTOSAR Builder?
Oh, that's a good question. AUTOSAR Builder, I haven't mentioned this. AUTOSAR Builder provides also a capability for unit test or system test, which means that you can either test individual software components or your full software architecture. And how we do that, we generate an AUTOSAR compliant OS and an RTE, a test RTE, which implements all the let's say the functionality and behavior like a real OS and a real RTE. So the RTE, you know, is implementing the communication in terms of sender receiver and client server communication, and the OS is, for example, implementing the task priorities and so on. And today we use our own OS, which is really just targeted for simulation or testing, but we had already quite some customer requests to be able also to integrate the operating system, but also the RTE from Elektrobit. And we have actually already a prototype running where you can test software components or the software architecture taking the OS and the RTE from Elektrobit into account. So we are still working on that, and if there are any customers which are interested in this, we are happy to discuss this with you directly.
And is it possible to emulate the whole ECU on Windows or Linux, for example, for software and loop testing purposes?
Mm-hmm. So on AUTOSAR Builder side, you could also emulate the whole ECU. So we do support here basically three levels of simulation. The first level, what we call the virtual functional bus level, takes the software components into account, including the OS and the RT. So this is what we call the VB level simulation. Then we have another level where we can also take a dedicated basic software modules into account. So these are, let's say, models of the basic software, like, for example, ECU State Manager. We can emulate a DEM, for example, a ComStack, an NVRAM, and so on. And then we have a third level of simulation, which we call the system level simulation, where we can connect virtual ECUs and also simulate the bus communication on a PDU level.
Okay, we saw during the live demonstration sort of how to use the two tools at once, but is it possible for multiple people on different stations to work at the same time on a single project?
Of course, as both tools are separate tools, the application developers work on the application layer, and at the same time, of course, the basic software configurator can work with Trees Studio. But I think what is here meant is probably a different answer. In AUTOSAR Builder, let's say there is some kind of quasi collaboration possible. You can lock certain files, which means those files are allowed to display but not to be edited. And by this, you can clearly control on who is changing what. So there's some kind of quasi collaborate working.
On the tresos side, we are currently working on implementing splittable support, also in typical AUTOSAR thing, and yeah, that's how we hope to be able to release soon.
Mm-hmm. So that's also a good point. Yeah, splittable concept is also supported in AUTOSAR Builder, which allows you some kind of collaborative working.
Okay, thank you. There's another audience member here who'd like to know, is there workflow support for model-based development?
Not sure how I answer the question because I would need some more detail. So model-based is a big topic. It can, of course, already start on the function level where you model your functions, and what's quite common here is using UML and SysML tools like Cameo or Rhapsody or Enterprise Architect. And from there, you proceed with on the AUTOSAR level. Yeah. So this is just, to my knowledge, there are a few possibilities available on how you can exchange data from a functional level up to the AUTOSAR level. But I think there's no really good solution on the market today. Yeah? So many customers try to implement their own things to fill this gap here. Yeah? Talking about model-based on an application level, there are tools like MATLAB Simulink or ASCII, which allows you to model the behavior of software components. And from there, you can also generate your target, your application code. Yeah? And what they also do, they generate at least a partial software component description, which you can then import in your AUTOSAR tool and then enrich it with additional data you actually need.
Okay, and I can see we've got quite a few other questions that have come in, with only a couple of minutes left, so we'll finish on one last one, and then I'm sure you'll be able to follow up with the audience members after the webinar itself. How do the RTE contract files from AB correlate to the EB tresos RTE generation later on?
Okay, so that's also a good question. So Tresos Studio provides an RTE contract phase generator, which you can, of course, use for application software components, but also for your basics software model, actually for your service components. Yeah? The reason why in AUTOSAR Builder there's also a RTE contract phase, because this is the place where you actually develop your application software. So once you've developed your software component in AUTOSAR Builder, then you can directly generate the RTE contract phase from there. So don't mix up contract phase with this full RTE generation. So we're really talking about the contract phase, which is generating the header files. Yeah? Of course, what you could also do, you develop your software component description into AUTOSAR Builder, import them into Tresos Studio, and use the RTE contract phase generator there. So this is up to you.
Okay, perfect. Well, I think with that, we can probably wrap up this session now. Thanks very much, Dennis and Michael, for your presentation and for your insight today. And thanks also to Elektrobit and Dassault for sponsoring the webinar. I'll note as well, if you dialed in late to the session or you'd like access to any of today's materials, don't worry, because we can send you a link to the presentation slides and an on-demand recording of the webinar within 24 hours. So again, thanks to everyone for listening. Make sure to check out our upcoming events. And with that, it's goodbye for now.